Alright, hi everyone. So in this section of chapter 1, we are going to start adding multiple force together. In this part, it will become very important to take into account the direction of the force to get an idea of the direction of the net force applied on an object. So the first question we are going to consider is question 7 on page 30. So let's first read the question. Question 7. A charge Q is equal to 2 microcoulomb is placed at the point P shown to your left. What is the force on Q? So obviously you cannot see the diagram, so I drawn it over here. We on the diagram, what we see is we have a first charge of 1 microcoulomb that is 2 meters away from a second charge of minus 3 microcoulomb. All right. We are told we're going to place a third charge over here, 1 meter away from the second charge of 2 microcoulomb. Now, one thing you will notice is that on the diagram, there's no notation for the charge. So here I decided that the first charge will be Q1. So Q1 is equal to 1 microcoulomb. Q2 is equal to minus 3 microcoulomb. And Q3 is equal to 2 microcoulomb. Now, as you will see in the next few examples, when we add multiple force together, it can become quite confusing really fast. So I'm gonna set a notation that I'm gonna use throughout the complete semester. So let's look at the first charge and the third charge. And by the way, the question is asking us to find the net charge on the third charge over here. That's the goal. So two pieces of notation I'm gonna use is the force vector between the third charge and the first charge. So the first number over here is the charge that we are considering. In this case, we want to know the net charge on the third charge. The second number is which charge is applying that force. In this case, it would be the first charge over here. Exactly the same logic with the force vector between 3 and 2. So it's the force from the second charge applied on the third charge. All right? Now, when we are dealing with anything related to multiple force acting on an object, it's always a good idea to draw a force diagram. So my force diagram over here is simply an X and Y axis. And I'm gonna draw on this diagram the direction of the individual force. Now, if we look here, the first charge and the third charge, they are both positive. In other words, they will repel each other. So that means the force of the first charge acting on the third charge is pushing the third charge in the positive X direction. So the force vector 3, 1 will be pointing in the positive X direction. That's an important distinction. You need to realize this in order to correctly add the plus or the minus in front of the one dimension vector. All right? The second force is between the second charge and the third charge. In this case, this one is negative. This one is positive. They will attract each other. So from the point of view of the third charge, there's a force pulling the third charge toward the left, toward the negative x-axis. So F32 is pointing in the negative x-axis. Now, one thing I want to highlight, and I talked about this in the vector section when I solved the example, is that we want to take the 2D vector and break it down into their 1D component. Once they are in 1D component, we can simply add the x together, add the y together, and then we can recreate our final vector that way. Well, in this case, the two force vector are already 1D vector. If we look at the force vector F32, well, this one is a 1D vector pointing in negative x direction. So in other words, the force vector 32 is equal to minus the magnitude in the x direction of this vector. Now, the magnitude will be easy to find here. There's no angle. It's already on the x-axis. All right? Same logic with the force vector 3, 1. So I added a plus over here, but just to highlight that it's pointing in the positive direction. And again, plus the magnitude of the force 3, 1 vector in the x direction. All right? Now the next part is we will write down the Coulomb force formula. So this formula is simply the Coulomb constant. I always use the absolute value for the charge because the minus of the charge is used to find the direction. And I find it way easier and way more intuitive to simply look at the diagram and add the plus or the minus. So for F32, we know it's pointing the negative x direction. There is a minus over here. All right. Now the distance is between the two charges. So our radius R is between the second charge and the third charge. It is 1 meter. Here we add 1 meter square. Once we compute the value, we get minus 0.054 Newton. All right. We repeat the same step for the second force vector. The only change here, well, there's two change. Obviously, we're not using the same charge. We are considering the first charge and the third charge. But the main aspect here is the distance between the charge. If you notice over here, we are told the distance between the first charge and the second charge. It is 2 meters. We are told the distance between the second charge and the third charge. It is 1 meter. So the distance between the first and third charge has to be 2 meters plus 1 meter. So I have my 3 meter over here, square again. Once we compute everything, we get 0.002 Newton or 2 millinewton. At this point, what we do is we add the x together and the y together and we create our final vector. In this example, it's really straightforward. There is no y component. The final vector is strictly pointing in the x direction. So we add the two vectors together and the net force is minus 0.052. I added this unit vector, the x unit vector, just to state that the net vector is pointing in the x direction, in the negative x direction. All right, so if you get 1D vector like this, you could simply say it's 0.052 pointing in the negative x direction. I'm fine with it, but you will see when we deal with vector having more than one component, often it might be just easier to add this component. Also, often I will ask you an answer in polar coordinates, so the magnitude and the angle will be important. All right, so depending on the problem, you can use the Cartesian coordinate or the polar coordinate. All right, so that's it for question 7. Let's move on to the next question.